we establish this, and also we note that f of x is not equal to f of negative x, since x cubed is not equal to negative x cubed. For completeness, we write this out. Now we'll briefly discuss the graph of y equals f of x equals 2 to the x. And again, our values, x and y values, negative 2, negative 1, 0, 1, 2. X values give us 1/4, 1/2, 1, 2, and 4 for the y values. And our graph could look something like this. Okay, if this is the point 1, 1, this would be the point 1, 2. In other words, if x is 1, y is 2. So that if f of x is 2, y is 4. Now I should probably draw 2 just a little bit higher than that. Okay, and graphs get a little messed up, but everybody understands this graph. We have the point 0, 1, negative 1, 1/2, so this value is cut in half, and negative 2, 1/4, this value will be cut in half when we come over here. Now I hope everybody is really secure about this graph, but I have noticed that it's gone on for too long that people still have not understood how to do a negative power. 2 to the negative 2 being 1 over 2 to the second. 2 to the negative 1 being 1 over 2 to the 1. In other words, 1/2. Make sure that everybody is on track with this. Okay, so anyhow, all of this goes with the x cubed function. We can dispose of the 2 to the x function pretty easily. Algebraically, f of 2 equals 4, f of negative 2 equals 1/4, so that f of 2 is not equal to f of negative 2. It's actually equal to the reciprocal of f of negative 2, but that's not particularly important for what we're doing right now. It's important perhaps later. But anyhow, f of 2 is not equal to negative f of negative 2 because f of negative 2 is 1/4. The negative of that would be negative 1/4. F of 2 is 4. They're negative reciprocals, but they are not equal. So we've already established that this function doesn't satisfy f of x equals f of negative x. Okay? Now, we've established it because in order to establish that it's not true that f of x is not equal to f of negative x, we only need one value where it doesn't hold. Okay? So right here is a value where f of x is not equal to f of negative x. We can't then say that f of x equals f of negative x. So over here I can say that, and I've lost my pretty blue chalk. Where'd it go? Okay. I can say for this function that f of x is not equal to f of negative x since f of 2 is not equal to f of negative 2. Now there's a way to say this a little more strongly, and to make this a little more logically correct, I use kind of a triple equal sign for always equal to, or identically equal to. This means f of x is not always equal to f of negative x, since f of 2 is not equal to negative 2. There's a value of x that contradicts the assumption that f of x equals f of negative x. And also, f of x is not identically equal to negative f of negative x, since f of 2 is not equal to negative f of negative 2. Okay, so showing that f of x equals f of negative x is false for any one value of x means we cannot claim it for all values of x. We can't claim that f of x is always equal to f of negative x. However, in these cases, just showing that it's true when x equals 2 doesn't prove that it's always true. Okay, now in this case, our conclusion's always true, and we showed it here by using the symbols. Just showed it algebraically, showing that f of x is equal to f of negative x. And here, algebraically, we showed that f of negative x is equal to the negative of f of negative x. And we showed that symbolically for any x in both cases. Okay, so just because something is true for x equals 2 or x equals 1 doesn't mean it's always true. To show that it's always true, we got to show that it's always true the way we've done here. Okay. On the graph, we see that we don't have equality, and I have to look at the tape here. I'm over time here, so I'm going to have to split this video, but that's not a big problem. Okay, so I'm going to continue since I'm over time. This one's going to get split anyway. So if I've got a value of x here, I come up to the graph. Here's my value of x. Actually, I kind of missed it there. But here's my value of x. Here's my value of f of x. Now, negative x is equal distance on the other side here, so here's negative x. And I come up to the graph, and I come over. And here's my value of f of negative x. Clearly, f of negative x is not equal to f of x. And clearly, negative f of negative x, which would just take this point on the other side of the axis, is not equal and opposite to f of x. It's too small.